Thank you for clicking on this video, and I'm about to show you that you did the right thing. This video is about something other than posture, breathing, trigger control, which are essential but not the focus here. To be a crack shot, you need to understand two things, and I'll make it uber simple. Sometimes things happen really fast in hunting scenarios, and the last thing I want you to do is to start playing with your elevation turret and guesstimating ranges. People are notoriously bad, including me, at estimating range. So grab a notebook, get yourself a drink, I'm taking you back to school. But before jumping in the thick of it, I need to explain some basic knowledge to make it more digestible to the complete beginners. So if you know what is an MOA, if you know what zeroing your rifle means, you can jump to the next chapter.
Provides a standardized way to measure and adjust for accuracy when shooting at distant targets, ensuring precision in aiming and adjustments with firearms and optical instruments.
Thank you, Professor. The best way to visualize an MOA is a cone with a very specific angle, 1/60th of degrees, starting at the muzzle all the way up to infinity. The beauty of the system lies in its simplicity, and let me expand. At 100 yards, one MOA measures 1.047 inches, but we will usually simplify it to 1 inch. The only thing you need to remember is that every 100 yards, one MOA grows 1 inch larger. So essentially, 100 yards, 1 inch, 200 yards, 2 inches, 400 yards, 4 inches, 1,000 yards, well, 10 inches. A rifle that is sub-MOA means that it can put 3 shots in 1 inch at 100 yards. This is your first equipment requirement to become a crack shot.
Zeroing a rifle involves adjusting the sights or optics so that the point of aim aligns with the point of impact at a specific distance.
The zero. To zero your rifle simply means to align your crosshair with your bullet flight path at a certain distance. Here in the example of 100 yards, it means that your eyesight will intersect the bullet flight path at 100 yards, and this is where your bullet's going to hit the bullseye. You could zero at any distance. Most folks will zero at 100 yards, but it's far from being optimal, and I'll explain that shortly. So, what does it take to become a crack shot? Maximum point blank range, or MPBR for short, is a way to ensure that your bullet flight path will hit a target of a specific size within a defined range. So here is an example of MPBR. For a moose hunt, with my setup, my rifle combined with my own reload, my maximum point blank range is 300 yards. Target size is about 20 inch, the vitals on the moose. So that means that when I put my crosshair in the center of the vital, my flight path, my bullet, will never go outside of that cone. That's my minute of moose. The bullet will never fly above or below 10 inch. Minus 10, plus 10, 20 inches. No need to second guess. You see a moose within 300 yards, it's literally point and click, or I should say point and boom. I do have another system for anything that is past 300 yards, and this is for a little bit later in this video. But first, let's see how to define the MPBR. I use a free online Ballistic Solver made by Hornady. It's great, fantastic. You do all the math, and then you need to go out to the range to actually test your result. But the step one is to actually gather all the information that you need to be able to solve your ballistic curve. Usually most of the information is going to be on the box of the ammunition that you buy. On the box itself, you should find the ballistic coefficient, and you'll see there's two types of coefficient. I'll explain that when we get to the computer in a minute. You need to know the velocity. I don't trust the velocity that is advertised on the box, because rifle varies, from rifle to rifle, and it's better if you can confirm your actual velocities. It's not essential, but if you could, getting a chronograph will tremendously help your process. You also need to know your bullet weight in grain, which is normally also on the box. And the fourth element you need to know is the actual scope height. And that measurement is taken between the middle of the scope all the way up to the middle of your barrel. And this is the offset between your line of sight and the line of sight of the barrel. That's important. So let's hop on the computer and I'll show you how I use the Ballistic Solver. A quick search on Google and you can find the Hornady Ballistic Calculator. This is the tool here. This is gold. So I'm gonna start with naming. I'm gonna set my distance to 700 yards. I don't need more. Interval at 25 yards, so we know what happened to that bullet at every 25 yards. My ballistic coefficient is 312 and the drag coefficient is G7. The velocity out of my muzzle is 2950. The weight is 165 grain. And my zero, I know my zero, I'll walk you through the exercise, but my zero is 200 yards, and I explain why. My sight height, scope height, is 1.5 inch, no need to change here. And the temperature of when I'll be hunting in fall is on average 30. So this is the chart, okay? For every 25 yards, you know exactly what's happening to your bullet. You have the velocity, you have the energy, and you have its trajectory in inch. So right now, I just want you to focus on the range and the trajectory. Energy is good all the way up to 625 yards. For moose, this is enough. So here at 0, you'll see that your bullet has an offset, and this is normal. And this essentially is the scope height, okay? Now, every 25 yards, you can see that the bullet rise till it reaches its apex, which is here at 125 yards, but never goes above 2 inch, okay? That's good. We're still within our minute of moose. So what we're looking for here is at which point the bullet will dip below 10 inch the vitals. And it seems that it happens between 325 and 350, because 325 is maybe a little bit too close for comfort. I like to give myself a little bit of leeway. I'm actually gonna cap it. I'm gonna cap my MPBR at 300 yards. So I know from all the number here with the ballistic, the velocity and everything that I have, my bullet is never going to be above 1.6 inch or below, where is it here, 6.5 inch. And this is good for my minute of moose. Now your question, I can see it coming, is yes, but you are way, within your limits. So technically you could push your 0 a little bit further, have your bullet fly a little bit higher, so you can maybe reach a longer distance. Yes, but no, and here's why. So if I close this, I go back. Let's say I set my 0 to 300 yards. Calculate. All right. So here we can see we're still below 10, right? So we're not even above 5, so that's pretty good. 300 yards, we reach our 0 as expected. And from here, because of gravity, distance, losing velocity, our bullet is going to drop really fast, okay? So if I increase the range of the 0 to 300 yards, this extends my MPBR to 375 yards. And that's still viable, okay? 400 yards, with a little bit of holdover you could do. To me, this is too close to comfort, so I'll do my cutoff at 375. You could be done with this. If you know you were never going to be shooting beyond that point, and whatever happened next don't matter much to you, you could set up your rifle this way, and that's still that works. Me, I prefer my 0 at 200 yards because of another advantage. And here it is. Subtensions and holdover. For anything past 300 yards, here how I use my subtension. This is my actual rifle scope reticle. The lines and space in between are called subtensions. I give names to these lines to help my process. The 0, the midpoint, and the max point. It's a second focal plane, which means the reticle size will not vary based on the zoom, but the subtension's relative size in MOA will vary as I zoom in. To make it simple, I remember my subtension at 10x. At 10x, the difference between my 0 and my midpoint is 5 MOA. Anything that I am looking through my scope that sits between the 0 and the midpoint is going to measure 5 MOA. Remember, MOA grow 1 inch every 100 yards. At 500 yards, that 5 MOA object will measure 25 inches. 1 MOA at 500 yards is 5 inches, and I have 5 MOA. So it's 5 times 5, which equates 25 inches. The same pumpkin at 250 yards is going to measure 10 MOA, because 250 yards is half the distance to 500 MOA. So in relation to the ballistic curve that I solved in the Hornady tool, so I know from my ballistic solver that my bullet will always be from 0 all the way up to 600 yards is going to be somewhere along these lines. And as reference point, I'm using my midpoint, which incidentally match my 425 yard at 5 MOA, and my maximum point, which is 10 MOA at 600 yards. So let's see how this works in the field. Between 0, actually this is 100, but between 0 to 300 yards, this is my maximum point blank range, so I don't need to do any adjustment. So I know from my ballistic solver that at 425 yards, I need to be 5 MOA down, alright? So this is my midpoint here. I also know that if I want to shoot at 600 yards, I need an adjustment of 10 MOA, which technically is the second line here, the maximum line. For anything that happens in between, because honestly, a moose will never specifically work on 425 or 600 yard mark, so it's gonna probably show up between these 2 points. What I'll do is I'll simply do some holdover, and I know between 425 and 600 yards, my bullet's gonna land somewhere in this area. So the only thing I need to do from here is, the closer I am to the 425, my holdover is going to look like this, because this is my 425 yard mark. And if the moose is past that, therefore my bullet is going to be below this point. And if the moose is closer to the 600 yard mark, then I'm gonna do my holdover more like this, where I know that at 600 yards, my bullet is technically shouldn't be lower than this. So it's going to happen somewhere in this area. This is why I find the system to be extremely intuitive. You have very few things to remember. I know there's a lot to do before, there's a lot of preparation, there's a lot of concept that you need to understand before you're able to boil down this recipe. When you have a good grasp on this concept, it's become very easy and very intuitive to walk in the field, range an animal, and shoot it without, much thought process. One thing I'd like to stress is the quality of the information that you're getting in the field to be able to make an accurate shot. And I believe one of the most essential tools that you can get is a rangefinder. The rangefinder will tell you with extreme precision what's the distance, because if you misjudge an animal within, especially at further distances, if you miss by 50 yards in your estimation, you can miss your shot. The main requirement for you to be able to do that is, yes, you need to have a rifle that is sub-MOA, and then you need a scope that is a little bit more complex than just the simple duplex. If you only have 2 lines, it's going to be a little bit more tedious to have proper holdover at a distance. So you want a scope that has some subtension lines that you can rely on. So your setup is going to be different, your ballistic curve is going to be different, your ranges are not going to be the same as mine. But with the tools that I just gave you, you can use my process and see how you can adapt it to your equipment to make it work. Now there's a section I wanted to do, but this video is going to be way too long, so I'm probably going to be working on part 2, where I will cover the environment, the wind, the temperature, pressure. It's somewhat important, not as much as we think we do. And I have a system, again, to simplify all this, to be able to quickly call the wind and decide how much correction it needs to have. And this is also based on your cartridge, right? I have 6.8 Western. It's relatively flat shooting, so that ballistic curve is fairly flat. High BC bullet will buck the wind better. And the only thing you need to give yourself is a frame of work, depending on what type of wind you have. But I can explain my process in another video. Let me know if you're interested in that. Until then, thank you so much for watching this video. And again, I know this is a lot, but watch it as much as you need so that concept fully gel in your mind. All right. See you folks. Bye-bye.
At At its apogee, the Moon is 252,078 miles from Earth, with 1 MOA measuring 70 miles. The Moon's diameter, 77,773 miles, equates to about 29.5 MOA when viewed through a rifle scope. Variations in the Moon's distance cause its apparent size in MOA to fluctuate. Good to know when aliens start invading.